In this new lesson, we are going to add on three new quadrilaterals. Um, these are all probably named quadrilaterals that you've had experience with previously, but what we're going to do is add some specific things about each one of them. So we're going to talk specifically about a rhombus, a rectangle, and a square. So just by definition, a rhombus is a four-sided figure that has four congruent side lengths. So as soon as I see a figure that has four congruent sides, it's considered a rhombus. A rectangle is a parallelogram that has four right angles. So as soon as I see a four-sided figure that has four right angles, it's a rectangle. And then the definition of a square is both of those two figures put together. So if a rhombus and a rectangle had a baby, their baby would be a square because it has four congruent sides and four right angles. So what we learn about each of these figures is that those aren't the only things about each one of them. So you may want to make note of this on your own. But if I have a rhombus, it actually has several properties that we can add on to it. So this is all specific to a rhombus. And what we're going to do is we're going to talk about the fact that if I draw the diagonals in, remember diagonals connect two opposite vertices, then the diagonals not only bisect each other like they do in a parallelogram, but the diagonals are also perpendicular to each other. So they actually meet at a right angle. The diagonals of a rhombus also bisect the opposite angles. So those two angles and those two angles are congruent to each other, along with these two angles and these two angles are congruent to each other. So a lot of different things happen in a rhombus that don't necessarily happen in a parallelogram. Same thing can be said about a rectangle. If I make a rectangle, what we know about a rectangle is that it has four right angles in it. So let me draw those in. So just based off of the definition, I know a rectangle has four right angles. So everything I'm about to say about a rectangle is specific to a rectangle only. So if I draw on the diagonals, they don't meet at a right angle. However, they are congruent to each other. So if I label my rectangle here as A, B, C, D, what we find out is from A to C is congruent from B to D. So the diagonals are congruent to each other. Now, just like in a parallelogram, the diagonals bisect each other, meaning that all four parts of those diagonals are actually the exact same length. So that happens in a rectangle. So if I tell you that this piece up here in purple is 10, so are these other pieces. If I were to tell you that one of them was 12, they'd all be 12. If one of them was 5, they'd all be 5. And that's specific to a rectangle. That does not happen in a parallelogram. That does not happen in a rhombus. That's specific to a rectangle. Things to keep in mind. I'm adding on these new specific things about a rhombus and a rectangle, and next I'll be doing the same thing for a square. But what we need to understand is all of these figures also carry all of the properties of a parallelogram. So they all have opposite sides congruent. They all have opposite angles congruent. They all have consecutive angles that are supplementary. They all have diagonals that bisect each other. And then there's one more. Oh, the opposite sides are parallel to each other. So a rectangle has all of those properties of a parallelogram and the fact that the diagonals are congruent to each other. A rhombus has all of the properties of a parallelogram on top of the fact that the diagonals are perpendicular and the diagonals bisect the opposite angles. So the last one that we're going to talk specifically about today is a square. And a square is special because not only does it have four right angles, but it also has four congruent sides. So again, this would be like if a rhombus and a rectangle had a baby, their baby would be a square. because you're taking the properties of those two figures and you're combining them into the properties of a square. So everything that happens in a rectangle happens in a square, meaning that the purple diagonals that I'm drawing in, they're congruent to each other. Everything that happens in a rhombus also happens in a square. So the diagonals are also perpendicular in a square, and the opposite angles bisect each other in a square. So the square has all of the properties that we've talked about. So if there's a property that we've talked about so far in this unit, a square has that property. So what we're going to do then is we're going to look at some problems, and we are going to use the properties that I just said, and we're going to answer some questions. So let's talk first. It says if you have a rhombus, QRST, so the first thing I'm going to do is draw a rhombus, and I'm going to name it that, QRST. It says decide whether the statement is always true or sometimes true. So in a rhombus, it wants to know, is Q always going to be congruent to S? Well, Q and S are opposite angles in a rhombus, so yes, this is always true, because this is a property of a parallelogram, which carries into being a property of a rhombus. And the reason why is because opposite angles are always congruent. And the next one it wants to know, is Q always congruent to R? So are the blue ones always congruent? This one is a sometimes. And here is when it's true. A rhombus, if I have it and I make it so that all four sides are congruent because it's a rhombus, if I also make it have four congruent angles, that means all of the angles would be 90 degrees. In that case, Q and R would be congruent. So this is sometimes true, and that time is only when the rhombus is a square. All right, so moving down, it says in a rectangle, FGHJ, decide whether these statements are true, sometimes or always. F and H being congruent to each other. Well, in a rectangle, all of the angles are 90 degrees, so this is always true. In the next one, it wants to know, are GH and HJ congruent? Well, in a rectangle, the opposite sides are always congruent. The consecutive sides are sometimes congruent. So this one is sometimes true. And the only time that this happens is only when the rectangle is a square. If I take a figure that has four right angles and I make it so that all the sides are congruent, then that rectangle becomes a square. In the bottom problems down here, it says name each quadrilateral that has this particular property. It's equilateral. Equilateral means all four sides are the same. There are two quadrilaterals we've talked about so far that have four equal sides. They would be a rhombus and a square. The next one says it contains obtuse angles. Well, a square has 90-degree angles, so that's out. A rectangle has 90-degree angles, that's out. The only possibilities are a parallelogram and a rhombus. It says it contains no acute angles. Well, a parallelogram can have acute angles, so can a rhombus. A rectangle can't because they're all right angles, so a rectangle would be an answer here. And a square can't have acute angles because all of the angles are right angles. In the next one, the property that the diagonals are congruent to each other, that happens in two figures. It's a basic property of a rectangle, and any property a rectangle has, a square also has. A square is just a specific type of rectangle. The last ones, the diagonals bisect each other. That's a basic property of a parallelogram. That's one of those 5 basic ones that we talked about the first day that we talked about parallelograms. If a parallelogram has that property, that means that every other quadrilateral we've talked about today also has that property. So a rhombus has that property, a rectangle has that property, and a square has that property. In every single one of those figures, the diagonals bisect each other. The last couple of problems down here, it says classify the special quadrilateral and explain your reasoning. So in the first one, I've got a 4-sided figure that I have 4 congruent sides marked on, which means that this has to be a rhombus. I can't be more specific than that because in order for me to say this would be a square, all the angles would have to be 90 degrees, which in this case is not true. In the next picture, I've got a 4-sided figure with 4 congruent sides, and I have a couple of right angles, which means that this has to be a parallelogram, and I know that consecutive angles in a parallelogram have to be supplementary, and I also know opposite angles in a parallelogram have to be congruent, meaning that this has not only 4 congruent sides, but it also has 4 right angles. Last one, I've got 4 congruent sides marked. I have an angle of 91 degrees, which means this can't be a square because the 91 degrees is not a right angle. So the most specific name I can give this would be a rhombus. Reason being, it has 4 congruent sides. In the next part, number 11 here, it says classify the quadrilateral first and then find x and y. So the first thing I notice is I've got 4 congruent sides and 4 right angles, meaning that this is a square. 4 congruent sides, 4 right angles means a square. So that means that all the sides are the same. So my 2 sides here marked with y have to be the same. My 2 sides here marked with x have to be the same. So this is as simple as just setting them equal and solving for x and y. So if I solve for y here, subtracting 1 gives me 3. Subtracting 2y gives me 3y. And if I divide, I get a value of 1. Setting the other 2 sides equal. Solving for x, I would subtract 5x from both sides, which would give me negative 2x. And if I divide by negative 2, I get an x value of 2. In the next problem, I have 4 congruent sides in this picture, no right angles, which means that my most specific name is a rhombus. Since I have 4 congruent sides, that means all I have to do is take my y labeled sides and set them equal. So a couple of things will solve this. We're going to add 5, we'll get 12. We're going to subtract 3y, so we'll get 3y. And dividing gives me a y value of 4. To find the x's, these are my 2 angles, s and t. Now since this is a rhombus, those consecutive angles are not equal. However, they are supplementary because that is a basic property of a parallelogram. And a rhombus is just a special parallelogram. So I'm not going to set them equal like I just mistakenly did. We are going to take them and set them added and equal to 180 because they're supplementary, not congruent. So adding my like terms here, I get 126. Subtracting 126 gives me a value of 54. And dividing by 2 gives me a value of 27. So I'm going to stop there, and what we're going to do to begin class, next class, is we are going to do these next three groupings of problems so that we can give you a chance to ask specific questions about these different properties, because they are very specific things for specific figures. So if there's a property you don't quite understand, like I kept saying, you know, a rhombus is a special kind of parallelogram, or this specifically happens when a rectangle is a square. If that wording kind of is confusing or you have questions about that, then you'll have a chance to ask those kinds of questions to begin class. So make sure that you have everything filled out until this point, and then we will go ahead and work through the rest of it together in class when we open class.